I'm Joyce Hornady. You might say accuracy is my business. I make bullets.
You are listening to the Hornady Podcast.
Thanks for joining us and enjoy the show.
Hello, everybody. Welcome back to the Hornady Podcast. Thanks for joining us on another episode. I'm your host, Seth Swerzik, and I'm joined today, popular guest on the show, to my right, senior ballistician Jayden Quinlan, and across the table, fellow marketeer, Preston. Thanks for coming on, guys.
Yeah, you bet. Maybe a little Quinlan's Corner episode.
Oh,
yeah.
dear. You guys did put me in the corner. I didn't notice that.
So,
It was inadvertent, but it turned out great.
For those listening, not watching, we do have Jayden into a corner, and as Preston called out, we'll lovingly refer to this as Quinlan's Corner, because what we have teed up for you today is a Q&A episode. So we get a ton of emails to podcast@hornady.com, comments in the videos, submissions to our general inquiry on our website, just a bunch of people reaching out, Instagram, Facebook, and we took some of the popular questions and some of the good questions that were brought up once we started our ballistic study. So we're going back now to in the mid-20s. We did our first episode of kind of a brief history on ballistics, and then we studied internal ballistics and measurement methods and external ballistics, and we're getting into drag and BC, and we're going to continue this study. But we thought it was a good time at this point to take some of those questions, get them out here on the table, and just get them answered for you guys, because a lot of people brought up some good points. And we certainly won't have time to get to all of them, because that would be a pretty long podcast, but we'll definitely take a good stab at it. And after this podcast, if you still have questions or as they come up, please do reach out to us at podcast@hornady.com, because we'd love to do another Quinlan's Corner.
Oh, dear. They had to do it.
Yeah.
Hey, you back me into a corner, I can get kind of scrappy, so look out.
Watch out.
I'm across the table. You better watch out.
He's got long reach over there.
Wow. Like Seth said, I've compiled a lot of these questions, and we're just going to try and go through as many as we can in a reasonable amount of time for a podcast.
Yeah, I think most of them geared towards Jayden, obviously, because he is really diving into some heavy stuff, and like he caveats every podcast he's ever been on the ballistic study. We don't have a textbook out here, and we do have full-time jobs outside of the podcast. So if we probably could sit down and take 4 hours to prepare and take notes and get like everything to the gnat's ass type of accuracy. But this is a conversational podcast.
Could, but we can't.
We
have a full-time job.
Yeah, right. So we do get some things wrong from time to time. We misspeak a little bit. Sometimes an analogy maybe doesn't work in your head like it works in our heads. So it's a conversational podcast, and we're just kind of off the cuff here.
Yep.
But I think it's working too. Like the amount of positive stuff that we've got from the comments and the people reaching out seems to be, though, even those that we're going to make some mistakes and we're going to say some things that don't work for some. It is working for others. So if it doesn't work,
majority.
Yeah, and if it doesn't work for some, hey, that's our responsibility to go back and either try to reframe that in a way that does work for them, or if there's a mistake made, definitely correct that. So.
Yep. Well, the first one isn't really pertaining to ballistics so much that we've talked about, but a guy wrote in, Dwight, via email to podcast@hornady.com, and he said, "Are strain gauges really that complicated to use? I'm not trying to diminish what the Hornady lab techs do, and I really don't have a good sense of what an actual strain gauge setup looks like. It's just one of those things that makes me wonder, why hasn't Moore's Law affected this?" Previously, he talks about how velocity, trackers, magneto speeds, lab radars have become so prevalent. Why haven't strain gauges at home pressure reading?
Yeah, that's a good point. I mean, your velocity is a really important thing, and like he says, we've seen the evolution of measurement tools and the price come down and the availability of different kinds and all that. Why haven't you seen that on the pressure front, which is arguably more important because that's a safety aspect, right?
Sure.
Really good question. Probably it's mainly because there isn't a demand for it on the consumer level, would be my assumption. I don't work in the field of pressure measurement device manufacturing or running that business, but that would be my guess. It's always been built for kind of manufacturing or industrial purposes. Mm-hmm. And strain gauges in particular, I mean, they can give you a idea or a direction on pressure, more or less, or kind of a somewhat of a quantification of it, but it's nowhere near accurate enough, in my opinion, to rival, the other methods that are used in the modern day method of measuring pressure.
Yeah. And correct me if I'm wrong, you have to give it a pressure for your initial reading.
A baseline.
To base the rest of them off of. And how does one know that? You really can't.
Yeah, I mean, you would essentially have to, almost like there's reference ammunition that's used to assess the condition of a barrel within, say, SAMI. You could do something along those lines, but that becomes there's not a well established system to support that. Yeah, I don't. And then you run the mercy of all the variables that you can't understand or quantify at just the user level. The type of steel in your barrel and the exact dimensions that are left and how that thing's going to handle that stress, which it's measuring. There's just a lot of assumptions.
Yep, I couldn't agree more.
I think it would be great if there was a consumer level product on the level of, say, a modern day chronograph that gave you pressure measurements. That'd be fantastic.
Oh my gosh,
we deal with problems galore of people assessing pressure measurements based off call it the archaic methods of how the cartridge case looks or how the
bolt lift.
Yeah, how the action feels. Whatever these different very broad metrics are that can be present when there's pressure. They can also not be present when there's pressure. I mean, there's not a one-to-one correlation there. So it would be cool if there was a tool out there to measure that at the consumer level.
But not yet.
Not yet.
Awesome. That's a good answer.
Yeah, you make some super good points there. A comment from YouTube on the BC and bullet drag video. Lower Mach gives a more normal shock, which has greater losses than the oblique shock at higher Mach.
Yeah, so kind of what that's referencing, we went through those pictures where we were observing that, the shock waves were changing position and the amount and all that kind of stuff. We were using that to explain that CD versus Mach graph. And he's just kind of given some more explanation to that is essentially what that comment is.
Oh, okay. All right. So another YouTube comment, some pretty stout criticism here, but we'll let you touch on that. Jayden, Mach number is a function of Reynolds number, and that is coming from the mouth of a so-called senior ballistician. Way to go, America.
Yeah, stout's a good description for that. Hey, rightfully so. So I made a mistake there in talking about Mach number and Reynolds number. Both of those things are really important. We were talking about bullet drag and explaining that CD versus Mach graph when I did that. Obviously, as we continued in that conversation, you saw us concentrate on temperature, which is your main driver. So essentially, Mach number is dependent upon the temperature and the gas that you're working with. Luckily, in our atmosphere, that's pretty much a constant. So the only variance is going to be the temperature, which is what we went into. Reynolds number deals more with the types of flow that are going to exist, which are still present and part of that CD versus Mach graph. They're kind of tied together. But yeah, he's right. I did make a mistake there. Hey, I'm going to do that sometimes. We're kind of doing this from the seat of our pants. So first, I apologize. That's my responsibility. But yeah, I made a mistake.
Yeah, and he's the only one that caught it. Must be a smart cookie.
Well, yeah, I was going to say across the table, you could have told me almost anything.
Just eating it up.
Yeah. Oh yeah. Yeah. Like a baby bird.
That's right. So this is an interesting one. Not really a question, but a comment. Jayden, on a podcast that you weren't even in on. Seth, you and I certainly were, but a guy said, I personally think synergy can make a considerable difference when talking about how well a rifle shoots or doesn't. 3 people can shoot the same rifle but not shoot the same size group. Same 3 on a completely different rifle setup, and results could differ again. And he's absolutely saying just my opinion, of course. This is on the Custom Rifle podcast, but I kind of have some thoughts on that. Do you have any thoughts about that comment?
Yeah, I'm not sure I'm well versed in synergy, but what it sounds like to me is that you get 3 different people shooting a rifle and you get 3 different results. Well, there's all kinds of variability from the input, the shooter that's shooting the rifle, but there's also rifles don't do the same thing every time you shoot them. It really depends on the sample size. You need that to be high enough to become stable to make comparisons between things. So if he's saying that a couple people lay down and each shoot a 3-shot group or a 5-shot group, yeah, most certainly I wouldn't expect the exact same results every time.
Do different things.
Yeah.
So you have to get your sample size high enough, and that will likely be a whole nother podcast in the future.
Yeah. Well, Preston, what's your thoughts on that one? You said you had some insight to that.
Well, mine went the same exact way.
Oh, okay.
He doesn't say how many shots are in
Yeah.
the group, so
Yeah.
I'm assuming
Well,
3 or 5, likely 3 probably. But
mentioned doing a separate podcast, and we will. But yeah, I feel like the general populace isn't shooting enough in a group size to get the actual dispersion of their rifle system, and so they see a lot of cloudy data from 3, 5, even 10-shot group.
Seth, this one's for you. We talked about our preseason pronghorn plans.
Yeah.
That's coming up.
Yeah.
But a gentleman said, not being from the USA, please explain how these tag systems work. And you've hunted of several different states.
Yeah.
Talk about tag systems and
Sure.
how that goes down.
Yeah, I'm not sure how it works in Europe, so maybe he could leave a comment on that. Well, here in the U.S., every state is different for the most part, and they're either their Game and Parks Department or their Department of Natural Resources, Fish and Wildlife, they will allocate a certain number of tags for a certain area, and within the state, you will have specific wildlife areas, and there will be a specific number of tags available in that area, and not everybody's going to get one of those tags, and they have a certain allotment for residents and non-residents, and then the states will have, the western states anyway, and some of the eastern states as well, like Iowa, for example, with whitetail deer.
Illinois, probably.
Illinois, I would assume. Yeah, it's those big, pipe hitter type whitetail territories. Anyways, they'll have a system in place to where you can apply for a tag, and if you don't get it, they'll have a bonus points system or a preference point system to allow you to build up credit, essentially, so that every year you go into the tag drawing with a little bit better chance than you went in before, and eventually you'll be able to draw those tags. So there are some states like Nebraska where if you want to hunt deer with a rifle, for the most part, nobody cares. Come over here and do it. And tags are cheap, and you can just buy them over the counter for the most part. But even here in Nebraska, there are places where to control the population and to try to better manage it, for either for trophy quality or for just the herd health, they will restrict the amount of tags, and it becomes a big game. If you're not familiar with the whole drawing process in a lot of these states, it's just a big game, and it's a frustrating game to play. And there is a phenomena called point creep, where you are saving up points to draw a certain tag in a certain unit, and when you started saving points, it would take, let's say, hypothetical, it'd take 5 points. Well, 5 years later, you're ready to draw the tag, but now so many people have been building up points, it don't take 5, it takes 7. And then so you get to 7, and now it takes 8, and then it takes 9, and it's kind of a big game. But again, they're hopefully these states are using science to dictate the level of permits available for the resident and the non-resident, and doing it with the herd's health in mind. Anybody else got anything to add on that?
I would say, and it's frustrating. It can be frustrating. Every state is definitely different. Some states are a true lottery, okay, and then some of them are literally preference points based. So in your example of point creep, that I would call that a preference based tag system. So if you have 5 points, you get the tag before somebody with 4 points.
Yep.
In a lottery system like Nebraska's elk herd, for example, you might have 5 points, but you get your name thrown into the hat 5 times. It's not like you can get it before the guy with 1 point because they're drawn out of a hat.
Like the bonus point system, where you get more entries, but
it's still anybody's.
Yeah.
Whoever. Yeah. I'm sure it's a computer, but anyway.
Maybe they do put him in a hat. Do you think they actually put him in a hat?
Oh,
they have this
definitely.
old Abe Lincoln top hat.
I bet Colorado these days has got to be a huge hat.
Big hat in Colorado. Yeah.
So Jayden, back to you. This is that same gentleman that comes at you with a high level of enthusiasm, let's say. But he says your example about the rocket launch is incorrect, totally out of place, and confusing. At the launch, the rocket indeed points itself into the wind because the wind is pushing on it. The fins at the bottom offer a much higher resistance to the wind than the other parts, so there is a torque that makes the nose turn into the wind. This is fundamentally different from the mechanism you try to explain that happens to a rocket at high velocity in the flat fire approximation. For the flat fire approximation to work, it is necessary that the rocket or a bullet moves at a high velocity, at least 2 orders higher than the wind velocity, along the whole trajectory you analyze. This fundamental condition is not fulfilled at the launch. The rocket does not interact with the wind the same way through its nose as it does at high velocity, and I don't think that I need to explain it to you further.
He's got away with words. Well, again, he's not wrong there, but I know that I caveated multiple times during that podcast that, hey, this isn't the same thing, but it's true enough, I think is what I had said, that we can convey it in a way that people might understand it better. And that was the whole goal. Obviously, I said that a rocket and a bullet are not the same thing and they interact differently. So, sure, definitely appreciate that level of criticism. It's always good to have that, keeps you in check. That wasn't the goal, and I will counter that with saying the mass majority of the feedback that I've seen from those analogies and from that specific podcast is that it was helpful in a way that people hadn't heard before. They had heard how wind affects a bullet, but it never really stuck with them. It was never anything tangible. Again, I use the rocket analogy because it's something that we can see, right? So we can observe that in more than just some theoretical drawing in our mind of words that are coming out. You can actually watch that happen. And the fact that it functions in the opposite regard as the bullet, right? It goes upstream instead of having deflection downstream from the way we had described it. It was effective in that manner. So again, when we're giving this podcast, we're attempting to cast a net that encompasses as many different listeners and their level of understandings as possible. So appreciate the criticism. It's always good to have that. But our intention was not to describe everything to the 100% technical accuracy in a way where 90% of people get lost, because that's what's been done up to this point. I mean, we're not the first people to describe wind deflection. You can go back and read all kinds of books and go through all kinds of stuff of listening to people describe it. And the majority of the time when most people leave those descriptions or those readings, they don't have any higher level of understanding than they did from the get-go. So the goal was to do it in a different way where hopefully it would be more understandable by more folks.
Sure. And he did mention after that the part about the crosswind weighting factors he liked, especially that a lot of trained snipers and experts spread BS in their YouTube videos about it. So, nice thing.
Hey, good deal.
A little cherry on top. Okay, so another YouTube comment. This is the very information that should be pushed and shooters should know. I'm very much looking forward to Jayden's assessment on load development and the truth of the number of samples required to distinguish between changes in the load and the respective changes or the perception thereof in group size.
I like the use of the word perception a lot in that question.
Yeah, you phrased it nicely.
He did, and probably understands some of the answer too. We've done a ton of testing on that. I think that should be a podcast in itself because there's a deep dive there, and it justifies the time of its own podcast.
Yep.
But I would say that generally in statistics, when your sample size gets to 30 or more, you're getting into good territory, and that's for good reason.
Another great question. I can't remember exactly which podcast this one was on, maybe the hunting ammo lines, but of your hunting bullets, which is the toughest or slowest to open between SST, ELDX, or interlock from 6.5 to 30 cal? Who wants that one?
I'll hit the wave tops and then Jayden can get into the specifics, but generally he could read his list of bullets backwards, and that would be the toughest to the thinnest, which would be the interlock would expand the slowest, the ELDX right in the middle, depending on the range and velocity, and Jayden could go into that because he helped design that, and there's some really unique features for that. And then the SST is going to be the most rapid expanding bullet with the thinnest jacket and the polymer tip to set that thing open.
You want details now?
Yeah, sure.
Well, the ELDX is going to be both the slowest and the fastest expanding, depending on velocity.
Yeah, that one's different.
Yeah,
for sure. But yeah, you're dealing with 3 totally different bullet designs there, especially from like a historical standpoint. You know, the interlock design or that exposed lead spire point design obviously predates both the SST and the ELDX.
By decades.
Yeah, and the benefits of that bullet is it's world renowned for expansion, right? It works really, really well for that. It does it at lower velocity impacts because it has that big amount of lead up front, so it's easy for it to expand. The downside of that bullet is its aerodynamics. That point is pretty big, and most of them are a flat base. There are some boat tail designs in there, but aerodynamically they're not comparable to what we have in the modern day. And then you see the move into the SST, which essentially was the first, polymer tipped, more sleek aerodynamic design from Hornady. And that bullet, although a king of its time in aerodynamics, can't compare to the LDX, which is essentially the next step in evolution of the aerodynamics. So you just see a slow, steady increase in how efficient the bullets are, and that extends your range or your minimum velocity, because as you go from interlock to SST, you retain velocity better with the SST. So that means that pushes you further down range that you can use that bullet within its intended design. And then when you go from SST to ELDX, it extends that envelope even further because it retains velocity even better.
Yeah, but I think you could group all three of these together and say they are meant to dump energy into the animal. They're expanders. They're rapid expanders. They're not just punching holes through stuff.
Well, and I'd say rapid controlled expansion, because on each one of those bullet lines, you're going to have a tapered jacket. The jacket's going to be thicker at the bottom and in its bearing surface than it is up front. And that taper is most aggressive in that ELDX. It'll have the thickest base, the thickest bearing surface, and then probably some of the thinnest up there towards the nose. And that's so that it expands rapidly, not rapidly, it expands easily when your velocity is decayed, say at 500, 600, 700 yards. But then it's got that thick jacket, so as it's expanding, it's holding together for those high velocity impacts. And both other bullets, the SST and the interlock, they do feature a tapered jacket to help control expansion, but none of them more tapered than the LDX. And then all three also include the interlock ring, which helps hold that jacket to the core. So depending on, if we're talking traditional range, say 400 yards and in, the interlock and the LDX are going to expand the slowest and be the most controlled, and the SST is going to be the quickest to more directly answer the question.
Sure. Awesome. Another gentleman from YouTube, thanks for the information. I understand that very technical points can be difficult to put in non-technical terms. Good job, a true mark of intelligence. Sorry, I don't want to make your head too big. I didn't realize I was just reading the nice thing.
Yeah, he's just filling your bucket here.
Yeah. But he also says, how does the humidity affect dynamics? In Arkansas, we have a very high humidity during the summer when shooting. In the spring through the summer, dropping to half of that during winter.
Yeah, humidity has an effect, but it's generally small in comparison to all the other things. So when you think about, say, the environmental units that you're concerned with in shooting, temperature, pressure, humidity. Pressure has a correlation with your altitude, so those two kind of go hand in hand. Of those three or four, however you want to look at it, humidity has the least impact, and so it's not really heavily concentrated on like temperature and pressure are.
Sure.
Especially at a traditional range. I mean, 400, 500 yards and in.
Almost
negligible.
Yes. Yeah. Other sources are far eclipsing changes in humidity's effect on your point of impact.
Cool. Well, the next question, also from YouTube, I got a question about the 6 degree of freedom, if anyone can answer it. What would it be used for? I mean, if we use a ballistic calculator, it's to predict where a bullet we shoot would land. Even if the end user would have what they need to get the right tools to put that initial yaw in, we could only get that number from shooting that bullet and get the angle to input into the calculator. But that would defeat the purpose of using a calculator to know where to aim if we have to shoot a bullet first, then get data that the calculator needs to tell us where to aim. Or would that be something more useful for research and development of projectiles?
Yeah, definitely more useful for research and development type stuff. That's what we use it for here. It does seem counterintuitive that you have to test the bullet to get the inputs that you need to get the calculation for the bullet. So he's definitely tracking there. But you can get some valuable info from that, especially with like your pitch and yaw rates and stuff like that. That yes, you might not know the exact orientation it comes out at, but that's one step closer to the ultimate accuracy in your prediction.
Cool. He's definitely doing better than me, though. That's for sure. It hadn't even come to my mind. So this one is Another one from YouTube. The 1,000 feet per second muzzle velocity bullet might drift less per second than the 3,000 feet per second muzzle velocity, but will it drift less over the entire distance, given that it takes so many more seconds to get there?
Yeah, so that's a good question. That analogy isn't put out a whole lot, or that comparison isn't put out a ton, so it can catch people a little off guard. But the purpose of that was we had essentially talked about another way to prove that wind deflection was tied to the lag time was we took a supersonic bullet, and then we took that same bullet and shot it subsonic, and it exposed them both to, say, a 10-mile-an-hour crosswind. And that if you looked at it from a time of flight perspective, they had spent an equal amount of time in the air. That subsonic bullet had less wind deflection than the supersonic one did. And the point of that was to convey that lag time dependence of wind deflection. It can be a bit confusing, and he's exactly right. If instead you looked at it from a range perspective, let's say instead of drawing a line in the sand of time, 1 second time of flight or whatever it may be, you did 800 yards. Most certainly you're going to have more observed wind deflection on target with the subsonic load because its time of flight is so much longer getting there. But that doesn't mean that the wind deflection is not tied to lag time. The opposite of that is true. It is tied to lag time, and that first example kind of exercises that.
And so this person also had another follow-up question, and maybe one not so easy to answer, but how do I become a ballistician? What's the career path?
I think there's a couple different avenues for it. Obviously some of the engineering fields are strong suited for it, mechanical engineering or aeronautical engineering. Physics in general, it's very heavy in that. I'm not aware of a single course of study, or curriculum that gives you a degree in ballistics. I'm not aware of that necessarily. It takes a whole lot of different fields. I mean, understanding, physics is probably the most encompassing one, because you're dealing with all aspects of it. Thermodynamics come into play. It depends on the field of ballistics too. You have 3: internal ballistics, external ballistics, terminal ballistics. I'm fortunate to get to dabble in all 3 of them, and yeah, you touch a whole bunch of different areas of study or education, I guess, in that.
I would say that there's also not a huge group of people in the industry actively searching for ballisticians.
Yeah,
There's not many.
Yeah, right. Like there's only. I mean, if you're focused on firearms, there's not a whole lot of companies that have the equipment to justify having a ballistician. To have the laboratory like we do, and then how many do you need times however many companies there are that could justify them. It's a pretty small field, so that's probably why you don't see at college that you can get a degree in ballistics.
Yeah, and it's probably relatively challenging to get in those small amount of places that need a ballistician.
Yeah, well, take Jacob Morrow, our new ballistic lab technician. He's on his way to becoming a ballistician, and his first step was talking to Jayden and joining the Air Force, doing Doppler radar drag reduction or drag analysis rather, and getting his foot in the door here at Hornady, doing something else that related to bullets and accuracy and that kind of stuff, but and then just being patient.
Yep.
And learning and seeking out education and knowledge as available, and just kind of learning, trial by fire. Formal education, military education is kind of all encompassing to get him here and to get him on the path.
I think the most important thing is passion, though.
Oh yeah.
If you've got the passion for it, you'll find a way.
Yeah, those are some excellent points. Another YouTube comment. Thank you for the explanations. I had previously not understood why the BC had a larger impact on wind drift than I would expect from just slightly reducing time of flight. This is where he gets into his question and or comment. I'm afraid the crossing the river analogy does not work for people who actually have experience in swift water, though. The problem is the gradient of water speed, which is similar to wind gradient. Slow flow near the bank and faster flow away from the bank as the water gets deeper. The bow of the boat encounters increasingly rapid lateral flow as it moves away from the bank, turning it away from the flow rather than into it. If you push a canoe out into a fast-flowing river, it will immediately point downstream instead of pointing into the flow. Otherwise, I understood the concept of lag time, just had to ignore your example. The rocket analogy doesn't work for me either, since I know that almost all larger rockets are controlled by guidance systems that counteract crosswind effect. I guess I should play with fireworks more.
Definitely.
Absolutely.
No, again, I'm using analogies that are trying to they're different, and they're trying to get to people in a way that is not just the standard. Well, this is how you answer this question, because we know those aren't effective. They've been around forever. So, the kayaks in the river analogy was just to give a different way to understand what I was trying to describe there, with how those three different things respond to that flow, which is essentially what wind is. The thing to keep in mind there is that you have to concentrate on the bullets, the relative velocity vector with how fast it's moving, and the wind. Those are two totally different values. Your bullet's traveling at thousands of feet per second, and a river or whatever is not. It's
Right.
in the teens. So you have to keep those two things in mind. But again, most of the feedback we've got said that analogy helped. So I apologize it didn't work for you. You're not going to catch everybody. But sounds like he already understood it anyway. Again, to his rocket point, along with the other comment on rockets, I had said that
You probably need to scale down your idea of rocket for that analogy.
Yeah, I had said that they're two different things, but we're going to use the analogy simply to convey the fact that it's doing the opposite of what a bullet would do.
All right, another YouTube comment. This one from the which ammo line would you choose? Maybe they could expand on why they refuse to make any 260 Remington ammunition. I saw it in their catalog once, but they no longer, as far as I can see, offer any 260 ammo, as it is a direct competitor to the 6.5 Creedmoor. The cartridge that has done nothing that previous 6.5 264 can do equally or better. They stood on all that came before in the world of 6.5mm cartridge and ammunition makers and picked a cool name in Creedmoor. Package it and send every single gun writer to Africa, North America, and anywhere else to hunt for publicity junkets, and for them to use the 6.5 Creedmoor, so they'll write it as the end-all be-all cartridge in the 6.5 264. And you need not look any further than to their 6.5 Creedmoor. I apologize if I'm stumbling at all. This is not the most well-written comment I've ever seen. He says, am I biased? No. However, when I get my latest issue of Shooting Times and there's 5 articles on the 6.5 Creedmoor in one magazine, yes, I question Hornady's advertising and free hunting trips to promote their effort to kill any and all competitors to their beloved 6.5 Creedmoor. All I can say is literally get a non-Hornady biased reloading manual and compare it, the 6.5 Creedmoor, to other 6.5 cartridges, and you'll see Hornady offers nothing of any percentage worth switching to their cartridge for. In fact, the Creedmoor hamstrings the round, and it is not able to perform with various other bullet weights in the 6.5mm family and the Hornady round cannot do to a smaller case. Again, apologize for the phrasing here. Not saying it's a bad round by no means, but a 260 rem, 6.5 Swede, 264 mag, or even 6.5 rem mag can't duplicate or, in many cases, well exceed the 6.5 Creedmoor.
I'd like to answer this one because, well, Jayden can answer too, but being on the media side of it now, so first off, we still do make 260 Remington ammunition. We still do our 129 grain Superformance SST for a hunting load, and in ELD match, we do 130 grain ELD match ammo. And the reason those bullet weights are selected is because the 260 Remington has a standard SAMI twist rate of 1 in 9, which is insufficient to properly stabilize the really, the long, heavy, popular match bullets in 6.5. So we still do have some factory ammo options out there for the 260 Remington shooter. And I mentioned the SAMI twist rate because I think that's the prime example of what the Creedmoor does that the 260 Remington doesn't. And the 260 Remington, properly hand loaded and with the proper chamber and twist rate, it's a great cartridge. You can really push that thing to do some cool stuff. But you can't let everybody do that because not everybody hand loads. So when you're married to SAMI dimensions and standards, the 260 Remington leaves some on the table. Mm-hmm. Not only does it lack the necessary twist rate, with the case length and the allowable head height, you're not going to be able to run the 147 grain or the 143 grain ELDX because it's simply too long. So for the hand loader, the 260 is great, and the 260 improved would be even cooler. But again, if you're a custom hand loader or you got a custom rifle, then run whatever you want to. The 6.5 Creedmoor allows for the really long, super low drag bullets. It's got the proper head height to seat those bullets out where they belong. It's got the right twist rate for them. And then all the dimensions are standardized. So you can buy the $400 Ruger American and it's going to shoot lights out, or you can buy the $4,000 custom rifle and it will also shoot lights out. And kind of that goes into my next point with why you're seeing 5 articles or several articles per magazine on the 6.5 Creedmoor. And these writers, they don't want to write negative things. So if you're getting a gun to do a review on, do you want to get a standard SAMI 300 Win Mag chamber or a SAMI 308 chamber? Or do you want a 6.5 Creedmoor chamber, which is going to absolutely pound knot holes with everybody's ammo? So if it were me, I'm going to do the review on the gun chambered in something that I know is forgivingly accurate and is going to shoot well, and is popular for that matter. So hopefully that at least somewhat satisfies that question about, is it, are we just trying to push the cartridge because it's ours? No, we're pushing it because it's very easy to be accurate with. And as far as the all expense paid trips to Africa and stuff, is the 6.5 Creedmoor a good hunting cartridge? Yeah, for the appropriate game at the appropriate distances, the 6.5 Creedmoor is a fine hunting cartridge. Although there are a lot better ones, and I think you'd ask anybody here at Hornady, will be the first to tell you, is it a versatile cartridge that you could go hunting with? Absolutely. I've killed a bunch of animals. I'm not taking it elk hunting. Would I? Yeah, with the appropriate distance and bullet, but it's not my first choice. And those other cartridges mentioned, the 264 Win Mag, the 6.5, the 260, 6.5 284, 6.5 Sweet, all those, they all have great attributes, but all of them lack the standard dimensions and standards that make them easy to be accurate, and factory ammo's got the bullet options that people want that is consistent. And I think that's one thing that the Creedmoor has in spades is, regardless if you buy a really affordable rifle or a really expensive one, or really affordable ammo, or really high quality, incredibly precise match ammo, it's all going to shoot reasonably well from any of those combinations, and that's because it was designed for that. And I think that is not easy to digest for some people that really don't like the Creedmoor for not liking its sake, but it just so happened that it fits a lot of uses. I mean, it's super, super utilitarian.
Yeah.
Whitetail deer, antelope,
everybody
matches,
loads ammo for it now.
And everybody loads ammo for it. It's
not
just
ours.
It's just easy. And so, that's my take on it is that, yeah, is there better hunting cartridges out there? Absolutely, depending on what you're hunting. For hunting things like whitetail deer or antelope, it might be one of the better cartridges out there. Super easy to shoot, easy to be accurate, low recoil. I've shot it, you've shot it, we've all shot it in matches for years. Versatile, factory ammo is great. The amount of rifles out there that you can just go to the store and buy that have all the stuff you would want in a custom rifle, and you're buying it off the shelf. What more does the guy want? So I don't know, that's my take on it.
Yeah, and at this point, you kind of have to look at demand as well. It's like,
oh yeah, there's no question. Yeah, the demand isn't there.
Can go to any gun store and look at the shelf, and there's not a bunch of 260s sitting there, but there happen to be a bunch of 6.5 Creedmoors. What do you think we're going to do? Make a bunch of 260 Remington ammunition? No, we're going to go where the demand is. Mm-hmm. So we still have offerings for those people that have those guns and want to get those guns.
Yeah. I
think people get kind of romanticized with maybe their first gun, or they had a 264 Win Mag way back, and the 6.5 Creedmoor can't do anything. But it also suffered from the same twist rate ailment.
Oh yeah,
it's the 260 Remington or many others. But and then maybe Jayden, you can go into that a little bit. But the standardization process through SAMI, we have to stick to it.
Yeah,
for a lot of good reasons.
Yeah, I would agree with everything that both of you said, and maybe just try to add a little bit to it. Of the Creedmoor is arguably the most popular cartridge in the United States for a couple of years now, I would say. And you don't get to that position by simply marketing force alone. That cartridge has to be able to stand on its own merits to be able to become that widespread for other ammunition manufacturers to pick it up. Obviously, there has to be a business interest, right? There has to be demand enough to justify them adopting that cartridge and loading it.
Money.
So all those aspects would go against what he's saying. And I understand, just because the 6.5 Creedmoor is as popular as it is, doesn't mean that all those other cartridges are useless and can't do anything. That's not the point. I think taking a look at things from that historical perspective and understanding that at the times when all those other 6.5s he listed were standardized, there was no 6.5 147. There was no 153 grain A-tip. The bullets of that era, all of those cartridges were designed with those in mind. And you can see that in hindsight when you go back to the 9-twist, the heaviest, sleekest bullets of those eras, the 9-twist would handle those. So why would you design it for some future unknown? You wouldn't. So what happens? Things evolve. We learn things and make bullets in new ways where they're better, they're more efficient. Things keep progressing. Well, you reach a point where in projectile design, you've made things so advanced you no longer have a cartridge that can use the great projectile you just designed. So what are you going to do? Stop projectile design and quit advancing? No. You're going to design a new cartridge that can take into account all of these new projectile designs and be able to use them. And the fact that that's what the 6.5 Creedmoor is no throwback to saying the old ones are useless, but they're limited by their time that they were designed and standardized.
Very well put.
Yeah, unless
And
you're
I think
custom
people
rifles.
forget that the 6.5 Creedmoor was out for many, many years before it really became in vogue or super popular.
Right.
Like a long time. Introduced in 2007.
Mm-hmm.
I had no idea what it was in 2007. Did you?
No, I didn't know. Yeah, I learned about it in like 2012.
Yep. Yeah. So that's pretty interesting little caveat. Anybody can answer this one here. It's a YouTube comment. This gentleman, I believe, needs something in the Superformance line. He wants Velocity, 300 Win Mag, and 308 Winchester. Thinking about trying the CX Bullet. I don't know. What do you guys think?
Well, we might be on the same page. Might not. I don't know. For me, I got to know what he's hunting. So I don't know what he's.
You don't get to know.
I don't know what he's after, but my answer would be the same regardless. In my opinion, what I would do, Win Mag or 308 Winchester, whichever, is go Superformance and go with the lightest CX bullet that we offer. With the 300 Win Mag, I think we do 165 grain CX in Superformance. Now, that is an absolute hammer. So those bullets quickly gained a reputation for just being devastating. Excellent terminal performance, and they thrive on speed. The faster you drive them, the better they work. So you go with a lighter bullet weight to get the velocity up. Plus, it's a Superformance propellant, so you're getting that 1 to 200 feet per second over a standard velocity with that bullet weight. And now you're screaming, got all the velocity, but you know that bullet is going to hold up really well. You're not going to sacrifice anything. It's going to retain 95% of its weight, likely going to give you an exit hole. Just the right way to do it, in my opinion. If you're going to go Superformance, if you need that hot, nasty speed, I'd recommend going with the lightest CX bullet option that we offer.
Yep.
I don't think there's much more to say to that one.
Nope. Nailed
it right on the head. Rusty asked a few questions on YouTube, but I'll skip to the really, really, really good one. Sorry, we're on a little bit of a stretch for time here, but I used to buy 1,000 284 AMAX a year, but then it came out that the tips were melting, so I had to switch to solid copper bullets. I don't want melted plastic in my meat.
Hey, good point. The plastic isn't melting. The plastic tip isn't melting. It's actually deforming. It's just changing shape a little bit, and that's what we were observing in the drag curves back when you see heat shield tip come out in both the ELD match and the ELDX. So from a hunting perspective, you don't have to worry about that, and essentially the effect between either of those would be the same as far as the meat's concerned, I guess you could say.
Yeah, at the point of impact, I believe the polymer is probably solid enough that there's not going to be any melted plastic.
Yeah, and we recover bullets all the time out of animals that we hunt or in gelatin, 10% ordnance gelatin that we use as a test medium, and you recover the tip. I mean, if he's shot animals with those legacy bullets and he shot some with the new ones, the same state that he found the tip in the old ones would be what he's going to see in the new ones.
Yeah, and I've always thought that the tip melting was kind of an overstatement because it melting to most people think of like an ice cream cone melting in the sun, but it's simply reaching a temperature such that the oncoming air can make it deform, just change shape. So it's not melting and dripping off.
Right.
It's just getting softer.
This person said, "Get a whiteboard. A drawing's worth 1,000 words." Smiley face. Well, we
Not
did you
my-
one. We did
not-
you one better later on.
Not Jayden's drawings.
Not if you've seen my drawings. That comment would get deleted.
It looks like
real
John
quick.
Madden up here trying to to describe ballistics. He put an X over here.
Oh, he also says, by the way, I think the transonic region begins as soon as shock appears on the bullet, M less than but close to 1, and ends when only the shocks are at the tip and behind the bullet.
Again, we're trying not to get so technical that we lose folks. And also a point of how that term is used in call it popular shooting culture. The term transonic, I would say, is used in a way where it's maybe
Little
outside
broader.
of those bounds
Like
that he
cavalier
laid out.
almost.
Yeah. And so in the conversation on that podcast, we were trying to address that aspect of it, kind of the popular culture reference to transonic, maybe not necessarily the technical Mach number
Right.
boundaries of transonic.
Gentlemen on YouTube, I have listened to this twice on podcasts and once on YouTube. However, I do not quite get the wind drift portion. You have mentioned that with AJ and spin drift that the nose of the bullet will point to the right and cause a drift to the right. Seems logical. However, in the wind drift section, you mentioned that a right wind will turn the nose into the wind to the right and drift to the left. Somehow I don't grasp that. What did I miss?
So spin drift is tied to normal force, and wind deflection is tied to bullet drag. So that's the important distinguishing difference there. The way to think about the bullet drag part and wind deflection is that the bullet nose does orient itself to the right for a right to left crosswind, and drag works in the opposite direction of the relative velocity vector. So being that the relative velocity vector is to the right from the crosswind, then the nose points to the right slightly, that means the left is mostly back, but a little bit left. And so drag is working mostly back and a little bit left. So that's why you get bullet deflection to the left, because it's enacted. The drag is what's causing that. The spin drift is caused by normal force. That's a different mechanism.
Fair enough. I even got that one.
I was thinking that was going to be a way more complex answer. I was like, oh man, we're going to clear the schedule here, but no, that was great.
All right. Here's an interesting one. And yeah, I don't think that it was brought up at all. And I've edited these podcasts. I've listened to these podcasts. I don't know that we talked about it. And maybe it's not a big deal, but you missed precipitations effect on a bullet.
Not much. A bullet has a boundary layer of air that's around it. I mean, it would obviously affect the relative humidity levels. No rain to rain, but outside of that, nothing really significant to discuss there.
So in layman's terms, it's a downpour. You shoot a supersonic bullet, or maybe subsonic for that matter. Rain's not touching it.
No. I mean, we've shot in plenty of
yeah.
circumstances where it's that way, and they go where they're supposed to.
Yeah, except this is a perfect example of an old Marine Corps saying, rain affects the shooter, not the bullet. Good to go.
All right, an interesting question on YouTube. Awesome, thanks for the info. I'm about halfway through. That's inconsequential. But can you guys talk about barrel whip, barrel harmonics, and if that is a consistent direction and frequency, assuming all other variables, velocity, bullet engraving, alignment, etc., remain the same? My understanding of a node when reloading is when barrel whip is in the same position at the same time of the bullet uncorking every time. Maybe that's wrong.
No, I would agree with that as maybe a definition, one of maybe many of what a node would be. That term's thrown around a lot within the shooting community.
Yeah, it is.
But in reference to his question on like harmonics and stuff like that, yeah, they certainly exist. I think they're probably romanticized a little bit more in the modern day. They might have had more of an impact in the past. I think that the quality of our barrels, mainly how the bore is drilled in the steel, has a big part to play in that. So one of the sources of harmonics that you would see would be if the bore through the barrel is not straight, it has some change of direction to it. So you could view that as maybe like if you held both ends and then spun the barrel around and you look through the center, it would look like the bore was almost like a jump rope. Anybody that's chambered a barrel has probably observed that to a greater or lesser degree or seen it. So when the bullet is launched, that initial, call it direction that it's going on, constrained by the barrel, left, right, up, down. If there's a change in direction of that hole that it's moving through in the barrel, the bullet's forced to change direction. There's going to be some energy that's exchanged between the bullet and the barrel at that point, and that could excite the barrel or cause a harmonic response to it, or a whip, or however, whatever term you want to use to describe it. So could you develop a load? So I believe it was the optimal charge weight load. I think the textbook application of that was trying to identify a point in the barrel's whip where it changed direction, and that would be your best load. There's probably some efficacy to that, but I don't think it's nearly what people hold it up to be, especially in the modern era. I think there's some other things that are going on. In the world of ballistics, it's always really difficult to isolate or control just one thing, because everything influences everything else. So it kind of becomes a garbled mess of the end result, So yeah, do harmonics exist? Oh, for sure. I mean, that's been proven, right? You can go back and look at like Harold Vaughn's work from Rifle Accuracy Facts. He did some really good work there and laid descriptions out that were pretty consumable by the average shooter. That's a great book if you haven't read it. But then also, there's been some material that's been released by the government on, say, the effects of different gas port configurations and stuff like that, like on machine guns, and robbing that gas off of one side and not the other could bend the barrel essentially at that point. Stuff like that. So yeah, those effects are there, but I think in popular shooting culture, they're given more weight than they might should. Or you think you're making a positive effect, and statistically, it's still lost within the noise.
Yep. You think you're seeing trends, but what you're really seeing is just
statistical
anomalies.
And I think we'll have a big old podcast about that. It's another one for a statistics podcast.
Yeah. Yep.
One topic I would like to hear about is the effect on pressure, resistance, fouling, or other issues from having a more aggressive twist rate than standard. Same question also for the external ballistics video. What are the negatives of a higher twist rate? Thank you.
Well, the negatives of a higher twist rate is that any imperfections in the bullet itself, so variances in, say, the jacket thickness of like a match style bullet, like a lead core copper jacketed bullet. If the jacket is more thick on one side of the bullet than the other, that takes the lead core and it shifts it to one side. And what that does is it takes your center of gravity of the bullet and it shifts it off of the center line of the bullet due to its form or its shape, the center of form. And so what you have there is a very similar situation to like an out of balance tire. And the faster you spin an out of balance tire, the worse the vibration gets. And a bullet is essentially the same thing. It's also the case of a bullet that exits the muzzle with an angle. It's crooked to some extent, which a bullet can engrave crooked into the barrel due to a whole bunch of different circumstances. Net result is that it comes out pointed a certain direction. It's not perfectly straight. Both of those examples, the crooked bullet and the bullet where the center of gravity is not aligned with the center of form, the faster you spin them, the worse they become from a dispersion standpoint. So your group sizes will open up. So generally what you'll see is call it a 1-to-1. So if I had a 10 twist rifle that was shooting 1-inch groups, and then I went to a 5 twist rifle, I might expect that to shoot 2-inch groups, doubling the twist rate like that. It can have some positive benefits on some of the really long aerodynamically designed bullets. There can be some drag benefits to it, but again, it comes at a trade-off of your group size could be opening up. It doesn't necessarily mean it will, but it can. So if you look at a lot of the bench rest shooters, most of them went like the slowest twist you could possibly go. That's the reason. They typically get better groups out of the slower twist barrels than they do the faster twist barrels.
Right on. You don't have to always go so fast.
And I want to hear Jayden's opinion on the pressure. Have you seen faster twist rates increasing pressure, all things equal?
Not within reason. And I would say, let's say we go from a 6.5 Creedmoor 1-8 twist to a 1-7. No, definitely not an increase in pressure. If you went to a 1-1 twist or something crazy like that, maybe. But I mean, that's extreme enough that that's not testing that we've really looked at. I mean, what's the purpose of that? So in general, no, it doesn't have a large correlation. Gain twists, though, we have seen some some evidence that gain twist can lower it, because you take 2 barrels, one's a standard rifling, one's a gain twist, and you shoot the same load out of both barrels, and the gain twist barrel will produce a slower velocity and slower pressure by a given amount. So that would maybe err to there's less engraving force or something along those lines that's occurring in that barrel versus the other. But what we found is it's essentially a moot point. You got to up your charge weight to get back to the same velocity where you were at before, and now you're back at the same velocity and pressure you were, but at a higher charge weight. And in general, that's putting more powder through the barrel per shot is generally not good for all of the longevity things we're looking for in a barrel, whether it's fouling and maintenance or throat erosion or whatever.
And I guess part 3 to that question, what about fouling? Does a higher twist rate increase fouling at all that you've noticed?
I think it could, depending on many other specifics. How much freeboard does the system have? What's the charge rate? What's the amount of propellant? What's the pressure that it's operating at? What type of steel is in the barrel? What's the rifling configuration? How many rounds are on the barrel? I mean, there's so many other things that are also an influence that it's hard to isolate that variable alone and say it does this or that. But in general, again, if you say you took a 6.5 Creedmoor and you went from an 8 twist to a 7, no, you're not going to see a dramatic increase in fouling.
Christopher says, where do you find max velocity for a 6mm Creedmoor? Sammy only has a 108 listed at 3,050 feet per second, I think. Where would I find max velocity for a 105 so I can find my max load?
While velocity is important and is directly tied to pressure, you can't simply use a max velocity per the SAME recommendations as your way of defining maximum load, because that's going to differ based on the burn rate of your propellant. A max load in a 6 Creedmoor, 41 grains of H4350 with a 108 is going to do about 3,000 feet per second. And 36 grains of Varget is only going to do about 2850. Both of them are going to have the max pressure, though, and pressure is what's important, not necessarily velocity. So definitely refer to a reliable reloading handbook published by doesn't have to be ours, certainly can be, but just a trustworthy reloading handbook to get your maximum charge weight. And if you're looking for a certain velocity, isolate a propellant that gives you that velocity. But you don't get a free lunch, and all powders will produce different velocity at different pressure. And one thing to be, I guess, as a add-on to that, it's not always velocity, but also RPM. Bullet performance. You can spin a bullet apart, especially in 6mm on down. Those smaller calibers. You can absolutely overspin a bullet, and anytime you start approaching to and exceeding 300,000 RPMs, regardless of what the velocity is, depending on what your twist rate is, that's something to be concerned with as well.
Yep. And I'd say ideally, as a hand loader, from a hand loader's perspective, if you can find the reloading data for the projectile that you're going to use from that company, that's great. Check for any differences in brass or primer; those might make small differences as well. If not, check the powder manufacturer that you'd like to use as data. Those are kind of my 2 go-tos.
Mm-hmm.
From there, if you can't find it, then you're kind of knocking on the door of kind of doing your own thing. So always start low and work up.
I would say just one more thing to add with SAME, though. SAME is a great reference to go to and look at for just a reference point that, hey, all the experts in the industry have agreed that the velocity tied to this 108 at max pressure is this. So regardless of whatever powder you use, if you're exceeding those velocities in that barrel length, you have pressure, because that load that's been published into the SAME manual is kind of the most efficient or most optimum setup out there. So if you're exceeding that, you're probably in dangerous territory.
So this one is a reply to a comment. This is from the Sub-X and Subsonic video. Jayden, you weren't even there, but maybe you can answer this if you'd like, or Seth, dive right in. But one commenter said, all the testing of the Sub-X 30 cal bullets I've seen shows the tip expanding to sub-caliber size, so barely better than heavy open-tip match bullets. Haven't seen anything about the 4570 or 450 Bushmaster. Do you have a response to that at all?
Yeah, you're not going to get traditional supersonic style expansion with a subsonic bullet. I mean, expansion is tied to velocity, and the fact that you're operating at a lower velocity means you're going to get lower levels of expansion. But the groundbreaking thing about the 190 sub X is it was really the first time that a traditional lead core bullet had been designed in a way where it would expand at subsonic velocities. So most subsonic ammunition up to that point was using both to hollow point style design, because you need that weight, to generate enough pressure to run a subsonic firearm. You don't have any terminal performance with those. It's all based on tumbling, and that's out of your control, and it's highly variable. So you get a bunch of different end results on the same shooting circumstance. So once the bullet expands and it does it reliably, that means you get very consistent performance, no matter what the variables of the shot are. But you're not going to get giant expansion with that. There was some other projectile designs that were out there that were a monolithic design that would kind of expand, but there's many downsides to that. One of them is certainly cost. Many of those bullets are made on a lathe, which is substantially more costly, and the material costs are higher. And in addition, generally dispersion or accuracy is not great with those. They don't have the ability to fill the bore. They don't have any give to them. So generally you result with a bunch of in-bore angle when shooting those, and your accuracy is pretty bad. So the Sub X was a different animal altogether for that, and it really gave the shooter an economical option to get decent terminal performance out of a subsonic load, which really hadn't been done commercially before.
That is supremely accurate compared to, I think, prior, expanding bullets, subsonically.
Yeah.
If you want to touch on, most of these people are seeing testing, or gelatin testing. I don't know if you want to touch on what you might see on YouTube versus what you can actually expect.
Yeah, certainly. I mean, we'll dive into that somewhat on the Terminal Ballistics podcast, which we need to do at some point, but you'll see a bunch of different test mediums out there. Really, the one that you should look for is 10% ordnance gelatin. That one's been shown historically to have a very good correlation to tissue, so live tissue. And there's some other stuff out there like clear ballistics and wet phone books and frozen chickens and all kinds of different
Gallons
stuff.
of milk jugs filled with water.
Just understand that, assessing the terminal performance of a bullet through a wet phone book tells you how that bullet performs through a wet phone book. 10% ordnance gelatin is dehydrated tissue that's rehydrated with water, so it's as close as we can get to living tissue, which has a certain moisture content and density. The stuff you'll see with some of the clear ballistics or those clear blocks is they're more of like a fishing lure type material, and they simply don't have the moisture content. They don't give you the same results that you're going to see in 10% ordnance gelatin or in live tissue testing.
Yeah.
So I guess summarize there, if you're seeing ballistic studies on gelatin on YouTube, likely you're not seeing ordnance gelatin.
Well, it's expensive.
very
It's stinky.
expensive.
It's hard to work with.
It's hard to work
Have
with.
to keep it cold.
There's a timeline associated with it.
Yeah.
To touch on his larger caliber Sub X statement rather than question, they perform amazing, and they expand, and they're transferring energy reliably and consistently, and that's something to drive home that, yeah, you're not getting 50-cent piece diameter expansion at 1,000 foot per second, but you're getting caliber and a half or more expansion, and it's transferring the energy versus, like you mentioned, a hollow point bullet or something that doesn't expand at all, that just tumbles over. That's not a reliable way to do it. So these larger calibers, they are expanding and transferring energy, and that energy transfer and that expansion is crucial for ethical quick kills.
And then potentially our last question coming from YouTube, Matt says, would testing at night eliminate a lot of the noise and solar flare?
Probably could. The difficulty there would be you need to have an aiming reference, which I guess you could illuminate whatever it is that your point of aim is downrange that's associated with where the beam is pointed. But that's not generally something that we've done a lot of.
Because, we are also fathers, husbands, we've got properties to take care of. We're going to come to this job with passion for 8 to 12 hours a day, but we've got to go home at night too.
Yep, kids got to eat.
Very well put. Well, Seth, that's really all I have for questions. You want to round this thing out?
Yeah. Well, we appreciate the questions. We really do. And again, there are a ton of questions submitted. We try to answer a lot of them.
Yeah,
I know
we
Preston's
couldn't answer all of them, unfortunately. We
No.
just ran into time.
Well, and I mean, this block of questions was really taken from the first ballistics podcast forward. So there's a lot of podcasts prior to that, a couple dozen worth that we tried to answer those questions either via Facebook, the podcast at hornady.com, email, or what have you. So these questions here, just from that block. So if you have more questions, please submit them, and we can continue to do these. All jokes aside from the Quinlan Corner thing, we can continue to do these because it gives us a chance, one, to interact with the customers a little bit more, which is awesome, and two, in the case that somebody misspeaks, we can correct that and get the right information out there. And again, we enjoy doing these conversational because I don't think anybody wants to listen to somebody sit here, Mr. Poindexter with a textbook open, just, kind of reading line from line. Like that's not good entertainment value. And, we've got other things to do. So the conversational aspect of it is nice. It's relaxing. I'm learning a ton so far. I know Preston's eating these up. He gets to listen to every podcast like 100 times.
Not 100, but multiple.
Multiple times. So, yeah, appreciate that, Jayden. Great job, as always. Always wonderful insight. Preston, thanks for hammering out the questions. Much appreciated, guys.
No problem.
Everybody out there in podcast land, thanks for tuning in on this one, and we will catch you on the next one.